How's it going? Today video I'm gonna answering question number 5, 6. The garden hose attached with a nozzle. It is used to fill a 8-liter bucket. The inner diameter of the hose will be 2.5 cm reduced into 1.25 cm at the nozzle exit. If the average velocity in the hose will be 2 meter per second, determine the volume and mass flow rate of the water. B. How long it will take to fill up the bucket. C. Average velocity of the water. So jump upon the problem solving. We have a device which is a nozzle that been attached at the outlet of the hose. So the hose will be attached on the inlet. So the inlet diameter will be 2.5 cm, and being stated that the velocity at the hose will be 2 meter per second. Later on, the water will enter the entrance of the nozzle. So at the inlet will be 2 meter per second, the velocity. And at the outlet will have a diameter reduced into 1.25. We were expecting the velocity will be increasing at the outlet. So analysis of the hose in the hose equal to analysis of the inlet. Question A asking about the volume flow rate. So the volume flow rate equal to V times by A. The V itself will be the velocity times by the area at the inlet. So the velocity at the inlet will be 2 meter per second. Meanwhile, the area will be pi times by 0.025 divided by 2 the power of 2. 0.025 I'm getting from the diameter. You need to convert 2.5 cm into SI unit. Then using the area equation for the circular. So we'll get 4.9087 times by 10 the power of -4 in SI unit. So 2 times by this value will get 9.8175 times by 10 the power of -4. So this will be the volume flow rate of the water at the inlet. Second question of A asking about the mass flow rate. So this is the conventional formula for mass flow rate. Mass flow rate equal to rho VA equal to rho times by the volume flow rate we denote as V dot. So we don't know what is the rho of the water at the inlet, but since that the water it is incompressible, thus the density of the water remain the same, and its value will be 997 kg per meter cube. It depends upon the temperature of the water, of course. I'm getting this information from the book of thermodynamics, right, by this person, Yunus A. Singer, Michael Abel, and Mehmet Kenoglu. So this is the part of the page that I'm quoting. Special case incompressible flow. Cancel the density of the both side because the density of the water in the inlet and the outlet will be equal. So we can just cancel it. And further, if you read, I'm just gonna stop right here so that you can pause this video and read it later on. But I'm just going to quote a little bit. For steady flow of liquid, however, the volume flow rate remains nearly constant since the liquid are essentially incompressible, which is constant density. So this means the density of the fluid will be equal in the inlet and the outlet. So that's why in the problem solving, I'm using the density of the water 997. I'm quoting from the table of thermodynamics A3 table, which is, as you can see at this row of temperature, there is a respect upon the temperature 0, 25 and 100. I'm just going to use this value 997 since that during my study this magnitude were constantly being used in any analysis, which is 997 as the density of the water. So I think for me, personally, prefer the questionnaire to to classify about the temperature of the water at the inlet, so that we can get used using the exact value. So I'm just going to use the 97 for the density. 97 times by the specific volume. Oh no, but the volume flow rate, we will get 0.97 at 8 kg per second. So that is the mass flow rate at the inlet. So now moving on upon the B question. How long will it take to fill the bucket with the water? So this is a simple math. If we know that the volume flow rate will be meter cube per second. So if we divide it by the area, the volume of the bucket, we can cancel out the meter cube, and the power this equation by -1, we can bring this s into upper side. On the equation, we will get the duration for water to fill 18 liter. So the final formula will be specific volume flow rate over by the desired volume that we want, the power of -1. So the desired volume must be in SI unit, since that the target of the volume will be 80 liter. You need to convert into meter cube. Thus we'll get 0.08 meter cube. We'll get the final duration of it will be 9 approximate into 81.49 seconds. So that is the question, the answer for this question. Last but not least, the average velocity of the water. I don't know how is it. Average velocity of the water. So we're going to use this equation. V in equal to the volume flow rate at the inlet equal to volume flow rate at the outlet. Since that the case in here will be incompressible, so the volume is conserved. We know that the volume flow rate in the inlet will be 9.8175 times by 10 to the power -4 from the previous question, equal to V times by the area. V in here will be the velocity of the fluid at the outlet times by the area of the diameter for the circular area at the outlet. 0.0125 divided by 2. You need to convert into SI unit, the power of 2 times by pi. So the final value for the velocity will be approximate into 8 meter per second. So I think that's all for today. Thank you for watching and have a nice day. Bye bye.